Assalamualaikum and hello everyone. My name is Dr. Nofarhayu binti Arifin. I will be your lecturer for this subject, which is Mechanics of Materials, BAA1133 for semester 1, 2020-2021. For information, in order for you to take this subject, you need to pass your engineering mechanics subject and then only you can take this subject. So let's begin with the introduction, which is a course synopsis and also the course outcome of this subject. For course synopsis, the aims of this course are to study the behavior of engineering or structure elements subjected to a loads, provide an introduction on elastic stress and strain analysis, axial deformations, and also analysis of column. Analyze the properties and behavior of engineering materials, including stress-strain relationships. Analyze of direct and torsional shear stresses and their deformation, shear force and bending moment of the beam, also the stresses in beam as well as the transformation of stresses. In a simple word, mechanics of material is to study the behavior of the materials when it is subjected to an applied load. What happened to the beam when you apply some load, and then what happened to the column when you apply the load. How about the stress and the strain inside the material itself? Okay, that's what we will analyze in this subject. There are 4 course outcomes of this subject. The first is for you to apply the fundamental concept of stress and strain to axial load and transformation in plane. Second is analyze the shear moment diagram as well as bending and shear stresses in beams. Determine the stresses, deformation and twist of angle of a torsional bar. Determine the magnitude of a critical load of buckling column. This is a subject schedule. So basically, there are 9 chapters for mechanics of material. First chapter is analysis of stress and strain. Second is analysis of strain. Third chapter is mechanical properties of materials. For chapter 4 is a axial load. Chapter 5 is an analysis of beams for a bending. Chapter 6 shearing stress in beam. Chapter 7 transformation of stress and strain. Chapter 8 torsion. Chapter 9, the last topic will be analysis of column. This is the assessment methods for this subject. So you have 2 quizzes, quiz 1 and quiz 2. Quiz 1 will be chapter 1 until chapter 3 and quiz 2 will be for chapter 9. And then these quizzes will be on column, which is online quizzes. Work-based project consists of 20%. Basically, I will give you after your midterm exam. Midterm exam consists of 20%. Usually, we will do after week 6, but it depends on the schedule by the faculty. Assignment 10%. And final exam will be 40%. So the total assessment is 100%. We use a mechanics of material by Hibler. And usually I give you a module, but since this is online class, so you need to refer to the slide given. That's all for introduction. Let's begin with chapter 1 of mechanics of material. Chapter 1 is analysis of stress. So why we need to analyze the stress? We need to analyze the stress because what happens if you are in stress? If you are in stress, then you will depress. Consequence when you are in stress. Same goes to the structure. When the structures are in stress, so it tends to deform. Okay, so that's why chapter 1 is very important because you need to determine the stress of the structure in order for the building or in order for the structure to remain sustained without any collapse, without any deformation. So let's take a look at the learning outcome. By the end of the chapter, you should be able to identify and apply the statics principles or equilibrium equations, isolated the rigid body and draw the free body diagram. As for introduction, mechanics of material is a study of the relationship between the external loads on a body and the intensity of the internal loads within the body. This subject also involves the deformations and stability of the body when subjected to external forces. The deformation here means that the action or process of changing in shape or distorting, especially through the application of pressure. Okay, as I mentioned in introduction, mechanics of material, usually we study the behavior of the material or of the structure when it is subjected to a load. So when the load is applied to the structure excessively, the structure will deform. And then the deformation here, it means by changing its shape and also a dimension due to the applied load. Okay, so everything, all the structure that you've designed need to be stable and in equilibrium condition. This is an example what will happen when the stability or the equilibrium is not be taken. Okay, so the structure will be collapsed. As a civil engineer, maybe one day you will design the building. So all the aspect of equilibrium and stability need to be measured in your design in order to avoid a collapse. First, we take a look at the statics principle. There are 4 static principles that all the structures need to comply. First is external load. Second is support reactions. Third is equilibrium equations. And the last one is the internal resultant loading. So we take a look at the internal forces first. So what is the internal forces? The internal forces is the forces. So for example, this is your structure. This is your elements in the structure. So this element, it is subjected to all the forces. Okay, for example, a surface forces. If you look at the definition, surface forces is caused by a direct contact of other body surface. So this is a surface force. So this is your structure, and then this is a force subjected from another elements. Okay, and the body forces is basically the gravity of the elements itself. So we take a look at the definition. Surface force are usually by the direct contact of one body with the surface of another. Okay, the contact between two elements. In all cases, these forces are distributed over the area of contact between bodies. How about the concentrated forces? Concentrated forces act at a point. Any load over a relatively small area compared with the size of the loaded member. Linear distribution load is produce a resultant forces having a magnitude equal to the area under the load diagram and having a location that passes through the centroid or geometric center of this area. So you already learned in engineering mechanics these types of loads. Okay, this type of loads we will apply to the structure, and we will analyze either the structure can sustain all this load or otherwise. For example, you have a structure. The structure here, so I assume this is a beam. Okay, this is your beam. There are different type of load, which is a surface load. You have a point load, and also you have a linear distributed load. So what does it mean by all this load? In the next chapter, you will familiar with all this type of load. First, you have a UDL, uniform distributed load. So this is a UDL, uniform distributed load. Okay, uniform distributed load, it will distributed equally in the surface of the structure. Okay, we call it as a UDL. Concentrated load, usually we call it as a point load. Point load, it's only at a point, only this point. Okay, linear distributed load, it having a different magnitude. Usually there will be in triangle or trapezoid shape. So the magnitude is different from 0 to the maximum magnitude. This one we call it as a linear distributed load. Okay, linear distributed load having different magnitude. Okay, I repeat again. Here is 0, here is the maximum magnitude. Okay, this is the type of load that we will analyze later. And then we go to the second principle, which is a support reactions. Usually, we have 3 common support that we use in mechanics of material, which is we have roller, we have pin, and also we have fixed. Okay, it will located at anywhere along the structure elements, depend on the design and depends on the application of the structure. Okay, for example, a roller. This is your beam, and this one will be your support. And for roller, they only have one support reaction. Okay, depends on the position of that support. So this one I name it as a AY because it is in Y direction, and I assume this is point A. Okay, you can have different, which is RA or HA, depends on the axis. Okay, second support is a pin supported. So pin supported, they have 2 support reaction, which is in Y axis and also X axis. I name it as AX and AY. Okay, you can also name it as R. R means reactions. And the last one is a fixed support. Fixed support has 3 support reaction, which is in Y direction, AY, in X direction, AX, and also a moment. I name it as a MA. How about the direction? How did I know AY upwards, AX to the right? Okay, I assume. Okay, you can assume all these support reactions, and then if you get the negative value, means that the reaction is contra with your assumption. Remember that you have 3 support. First, you have roller. So for example, this is your beam and this is your roller. And then second, you have pin connection. This is your beam and this is your pin. And third is a fixed connection. Fixed. This is your beam. For roller, you have 1 support reaction in Y direction because now the position of your roller is in Y. And second, pin. Pin, you have 2 support reaction in X and Y direction. And for fixed, you have 3 support reaction, X, Y, and also a moment. Okay, all the direction we assume. Okay, we assume first, but when you analyze, You assume and then you analyze. But if you get positive value means okay. But if you get negative value means the direction is opposite direction from your assumption. Okay. Now we go to the third principle, which is the equilibrium of a deformation body. The equilibrium of a body requires a balance of forces and balance of moment. So as I mentioned, all the structure need to be in stable state. How to ensure that the structure is stable? By applying the equilibrium equation. As you've learned in engineering mechanics, you have equilibrium equation, which is summation Fy equal to 0, summation Fx equal to 0, and also summation moment is equal to 0. Okay, the total force in y direction should be 0. The total force in x direction should be 0, and also the total moment of the structure need to be 0. So when all the equilibrium is complied, then you can say that the structure is stable or the structure is in equilibrium state. So the best way to account for these forces is by draw the free body diagrams. The last static principle is the internal resultant loadings. The internal resultant force or internal resultant loading is to hold the structure together when the body is subjected to external loads. External load is load we apply to the structure, but internal load is the inside force or inside stress that to counter back the external load that had been applied to the structure. Okay, the function of internal force is to hold the structure together when you apply the external loads to the structure. Okay, the objective of free body diagram is to determine the resultant force and the moment acting within a body. In general, there are 4 general types of resultant loadings, which is a normal force, shear force, torsional moment or a torque. The last one is bending moment. The torque you will learn in chapter 8. In chapter 1, I will focus on normal force, shear force and also bending moment. So normal force here acting perpendicular to the area, while shear force acting parallel to the area, and bending moment is a rotation. Okay, so let's take a look at the definition of each. As if this is your elements and this is the area that you need to analyze. So this is a normal force, which is normal force acting perpendicular to the area, while this is your shear force acting parallel to this area, and this is your moment. Okay, and this is your torsional moment that, as I mentioned, you will learn in chapter 8. Okay, here is a normal force acting perpendicular to the area. It is developed whenever the external loads tend to push or pull the two segments of a body. When you pull, you are in tension, but when you push, the elements are in compression. Okay, tension when you pull, compression when you push. Okay, for example, the wording is your elements. And the shear force lies in the plane of the area. It is developed when the external loads tend to cause the two segments of the body to slide over another. So this is your area and it acting parallel. Okay, it depends on the type of failure of your structure. The torque moment we know when it is twist. As like you spin your clothes after you wash your clothes, then you spin your clothes. So there's some torsional moment when you twist. The bending moment is caused by external load that tends to bend. So for example, this is your beam and it will bend when the load is excessive. This is an explanation of the direction of the internal resultant loadings. This is your element, normal force, shear force, and also bending moment. Okay, for example, this is your beam. Then you cut here. So we cut here. When you cut, for example, this is point A, this is point B. When you cut at A, you will expose all the internal forces. So internal forces, remember, internal forces or internal resultant loading. So you have normal force, shear force, and also bending moment. Normal force, the symbol is N, acting perpendicular to the area. Shear force, the symbol is V, is acting parallel. And the bending moment is a rotation, and the symbol is M. Okay, so this is the place where you cut here. Okay, and then you expose its normal force acting perpendicular. This is perpendicular, and shear force acting parallel, and also a bending moment. Okay, there is some procedure for you to analyze the structure. First is for you to determine the support reaction. So remember, you have three support condition. You have roller, pin, and also fix. Each of these connection or each of these support, they have their own support reactions. For example, roller have only one reaction, support reaction. Pin, you have two support reactions. Fix, you have three support reactions. First, you have to calculate the support reaction value by applying the equilibrium equation. You have three equilibrium equation. Summation Fy equal to 0, summation Fx equal to 0, and also summation moment equal to 0. And then after you get the support reaction, then you draw the free body diagram to expose all the internal forces. You have three internal forces, which is normal force, shear force, and also bending moment. Torsion you will learn in chapter 8. And the last one, in order for you to calculate the internal forces value, you need to apply the equilibrium equation again. Summation Fy equal to 0, summation Fx is equal to 0, and also summation moment is equal to 0. For support reaction, you assume the direction, but different in internal resultant forces, they have their own sign convention. So you need to follow this sign convention. Okay, for example, you have a beam here. This is point A, this is point B, and then you cut it here. Then this is point A, this is point B. If you start your analyze from point A, This is your sign convention. The direction you cannot change. Cannot change the direction. You need to follow the given sign convention. Okay, if you start from A, your normal force should be to the right, and your V should be downwards, and your moment will be counterclockwise. But if you start from B, normal force should be to the left, your shear force should be upwards, and moment will be clockwise. Okay, make sure you did not change this sign convention for internal resultant forces. Please follow this sign convention for your analysis.